Hello, this is Kevin Moscow here, a GE Transportation Infrastructure Co-op. I'm here to give a Week 3 informal report on how my progress of the Smart Factory is coming. While I was researching for a Smart Factory, I first tried to find some advantages to help support my claim of investing in Smart Factory technology. The first advantage I came up with was increasing the productivity of the factory. I'll be showcasing more of this work in a body paragraph that I've written for my formal report. The second biggest point of emphasis that I came across was an increase in product quality. I found that you can increase product quality by taking real-time measurements, which come from softwares like Prophecy WebSpace, which is a GE digital platform software, where you can get real-time data from machines, such as if a part just machined is out of spec or if it's defective, and you can make an immediate change. Another type of data you get from product quality is long-term data. This type of data comes in the form of historical trends that you can analyze and start to tell if a machine is mining or machining parts that are out of spec, and you can try and make an adjustment before more parts are damaged. Both of this increase in productivity and increase in product quality lead to an increase in profit, which is really the bottom line of why we'd want to implement a smart factory. One thing I've been doing is looking at a cost-benefit analysis, and I've been looking at the implementation costs, which are presumably very high, versus the projected profit we'd obtain in 5 years. Now, the next thing I tried to research was drawbacks. I knew there had to be drawbacks. Something couldn't seem, so great on paper. And I did find a few, and actually found more than I expected to. The first main drawback that I found, which I anticipated, was high startup cost. You have to hire personnel that's familiar with setting up these smart factory sensors and devices, as well as setting up all these servers to link this information together. I did find one solution provider, Gray Matter Systems, which I'm going to use in my cost-benefit analysis. Also, like I said, the servers are very expensive, and some of these sensors can be as much as $4,000 for a single sensor. Another thing that I found is that you need a lot of cooperation from all the parties involved in the plant. You need cooperation from the machine operators, from solution providers, from line leaders, and even from the plant manager to shut down machines to install these sensors. And what I found is that a lot of the early statistics of profit from implementing smart factories are kind of delayed as people get used to shutting down machines and get used to this whole idea. Another thing I found, which is a little, disconcerting, is that a lot of failures happen with some of these new sensors. Some of these sensors will cause machines even to malfunction, and they might give bad data, which is just not good at all. The whole point of this smart factory is to get data we can use to analyze. Now, when I saw these drawbacks, I was a little concerned, so I decided to try and find some evidence to rebut these drawbacks or find evidence that they're improving. With this being said, one of the big things I came across is even though there's all these drawbacks, now is really the time to invest in the smart factory. A Frost & Sullivan analysis indicated that right now is the time when there's the most markets involved in developing these sensors and smart machines, as well as demand for these machines. So the price is fairly low, as well as a lot of good continued support from the providers of these sensors. And this graph here shows, a total grasp of all things that use internet, and the Internet of Things is these smart sensors and machines, and just projected to skyrocket. So we want to kind of be ahead of the curve on that, is what I found. I do have some next steps that I need to take. One of them is I really need to grind out my cost-benefit analysis. I need to look at the cost from all the implementation devices like sensors and even buying some new machines, as well as the cost for solution providers like Gray Matter Systems versus what an anticipated 5-year profit would be. Also, I'd like to find some signs that these drawbacks are improving, like these malfunctioning sensors, and I think I have found some improvements based on some Honda automotive reports. And also, I have a lot of evidence that I'm going to show you right now that I need to incorporate into body paragraphs and kind of assert. So if you go to here, I have a lot of quotes, statistical data, and visuals that help back these claims that I've made. Now I'm going to share the introduction paragraph of my increase in productivity body support. One of the most notable benefits of implementing a smart factory at GE Transportation's Grove City manufacturing site will be an increase in productivity. According to the Smart Manufacturing Leadership Coalition, SMLC, the addition of smart machines in a manufacturing environment can lead to a 10% increase in overall productivity. This increase in productivity will largely be seen from optimizing the operating times of machines and from having appropriate inventory to meet customer demand. I'll scroll down so you can see the rest of this and read it. And also, I plan to have my draft of my formal report finished probably by Monday, and I'll be able to submit a final rough draft by Thursday. And I guess you can see now I've been working on my cost-benefit analysis, and I'm going to incorporate that into my report. So thanks.